Having done a number of videos on exponential growth, I'd like to start talking about exponential decay, and I'd like to begin that discussion the same way we started talking about exponential growth, namely looking at a simple fact pattern where decay is occurring and trying to come up with a model for that behavior. So here we have a radioactive substance with a half-life of 1 year, meaning at the passing of each year, the current amount of that substance in grams is cut in half. And we're going to start with an initial amount of 1 gram just to keep the model as simple as we can. Just like the first video, we are going to plot some points in the coordinate plane just to see what points the graph of our model must pass through in order to adequately represent the behavior. On the vertical axis, we'll put the amount of the substance in grams. We'll use A of t for that axis, and on the horizontal axis, we'll use our variable t, which will be in years. The initial amount is 1 gram, so when t is equal to 0, we have 1 gram, so that gives us the 0.01. At the end of 1 year, this amount is cut in half, so we have the 0.112. At the end of year 2, this amount is cut in half, giving us the 0.214. And let's just put down one more. At the end of year 3, this amount is cut in half, giving us the 0.318. So our model must have a graph that passes through those points, and the model that does that, the curve that accomplishes that, is A of t equal to 1/2 to the t. So here we have an exponential function where the base is less than 1, and therefore it is a decreasing function. Much like exponential growth, we like to use base e for our exponential decay models. And as we've seen, we can convert to base e just by rewriting 1/2 as e to the natural log of 1/2, all raised to the t. Putting the natural log of 1/2 into your calculator and using the laws of exponents, we get that A of t is e to the negative 0.6931 t. Because this number that we're multiplying t by is negative, we get a decreasing function, right? And this number here is called the relative decay rate. Its meaning is very similar to the relative growth rate. At any point on this curve, the amount is decreasing because it's negative. It'll be decreasing at a rate equal to 0.6931 times the current amount present.